Hello everyone. This session I'll be explaining full adder using structural description. Objective is to understand the concept of full adder. Brief theory. What do you mean by full adder? So it performs the addition of three bits, that is two significant bits, and the previous carry will get added. It will give you the output as sum and carry out. Okay, so block diagram of full adder. So structural description we will be writing, that is structural description describes the components which are going to be used for that for full adder operation. So what is the full adder operation? What are all the components required in order to perform the full adder is? That is by using two half adders and one OR gate, we will be writing a structural description. So the two components are going to be used here. One is half adder and one more is OR gate. So the first half adder, input to the first half adder is actual input of the full adder, that is A, B, and output of the first half adder is S1, and output of the first half, one more output is C1. Okay. Next, input to the second half adder is S1, that is the output of the previous half adder, and one more input, that is the actual input of full adder. And output of the second half adder is, one is the actual output sum, and one more output is C2, which will be the input for your OR gate. So output of the OR gate, it will produce the actual output of full adder C out. So here we are going to write a program for full adder using two half adders and one OR gate. So in your program also, we will be writing a program for full adder first. In the same program, we will be writing a program for half adder as well as OR gate. Then how we are going to combine this half adder and OR gate, will come to know in the program itself. So let us come to the program part, simulation of the program. So this is the program for full adder. You can note down here. Okay, so from the first line to the 23rd line, this is nothing but the structural description of full adder. So here we have discussed from 1st to 23, we have discussed about full adder. Okay, so first part, it is the entity part. Entity part describes the input and output of a full adder. So input to the full adder have taken as A, B, C, I, and output is sum and C out. Architecture part, it will describes the components which are going to be useful for the full adder operation. One component that is required is half adder, one more half adder, and one more component is OR gate. So since we have used half adder twice, only one declaration is enough. So this is nothing but the declaration of the component. So your structural description consists of two parts. One is a declaration part, that is nothing but this, and one more is the instantiation part, which we will be writing inside the architecture. Okay, that is after begin. Now component, see component half adder. This will describe the half adder components. A half adder program. So input to the half adder is A and B, and output of the half adder is S and C. And what are the input to the OR gate? That is A and B, and output is C. Two input OR gate it is. And here for full adder program, you can note down in the block diagram, there are intermediate signals present in this full adder operation. That is, one is S1. S1 is acting as both input as well as output, as well as C1 and C2, it is acting as a intermediate signal. So it should be declared as signal in structural description. Next, begin the architecture. So this is considered as the instantiation part of structural description. This will maps the generic input with the actual input. Actual input is nothing but A, B, C, and actual output is sum and carry out. So the generic input is nothing but the input of your components, that is input of half adder and input of OR gate. So this instantiation part, it will maps the generic input with the actual input. This is about half adder 1, half adder 2 and the OR gate. Next, in the same program, you are going to write a program for half adder, because this is to, that program should be written inside the full adder program. Okay, that is why here it is given. You can note down here. So starting from the library itself, we have written the program for half adder till here, and this is the program for OR gate. So whichever the components you are going to use for a particular system, that should be the program for that program should be written in the same program. So when I save the program, what happens here is, save the program. Save it as type VHD. Click on save. Okay, next add the source. So while adding the source, actually to the device, 3 programs are going to be added. See, I'll show you that. Okay, see here. One we have written the full adder program. Inside the full adder program, we have written half adder as well as OR gate separately. That is why it will take the programs separately. So 3 files are going to be added to your device. Click on OK. Okay, now the next step is to synthesize the program. It will take some time to synthesize. Wait for some amount of time. Okay. So program consists of some error. Go through the error. So here 3 errors are there. So go to the errors first. Go to first error and try to see in undefined symbol C in. It is line 21. So we have declared the inputs as, see here how we declared this input as CI. So it should be declared as CI only. Save it and then synthesize. So if you get the error, clear the error, save it and synthesize. Okay, it will take some time. So it synthesized properly. Go to next step, that is change the sources for implementation to behavior simulation. Now the rest all the steps are similar. Select the test bench waveform, give a name, click on next. Here you should select the full adder program only. Click on next, finish. Okay, select the clock as combinatorial and click on finish. Now here select the input 0 0 0 0 0 1 0 1 0, next 0 1 1, okay, then 1 0 0. Okay, fine. Okay, that would be like this. Once you select the input combinations, save the signals, then click on sources, keep the cursor on your test bench wave file and then double click on simulate. Again it will take some time to simulate. Okay, now check the output. See here, the input is 0 0 0, so sum and carry out are 0. Go to next combination. 0 0 1. So what is the sum? 1, and carry out is 0. Go to the next combination. Here we have given the input as 0 1 1. So what is the output you are going to get? 0 plus 1 is 1. 1 plus 1 is, sum is 0 and carry will be 1. So this is how you are going to check the outputs. Okay, so this is about full adder program using structural description. So we have come to an end. Thank you.